Dear students, grade 11. Today's video we are going to complete the chapter about alcohols. Let's take a look at the learning outcomes and remember what we have studied in the previous parts. We learned how to draw and classify alcohols, and we have learned that there are three classifications of alcohols: primary, secondary, and tertiary. And you have learned how to identify each of them by just looking at the carbon attached to the functional group, which is OH. Also, the chemical reactions, we studied the chemical reactions of primary, secondary, and tertiary alcohols when they are oxidized. Second, decombustion, and then substitution to give halogenoalkanes, dehydration, and deduce the presence of CH3CHOH group in an alcohol from the reaction with alkaline aqueous iodine to form triiodomethane. Okay, let's start. We studied what do we mean by nucleophilic substitution. Okay, let's remember Now let's remember what is a nucleophile. A nucleophile is a species that actually can be an electron donor. Yes, it can donate electrons and it carries a negative charge. So one of the chemical reactions of alcohols was the substitution reaction by nucleophilic or the nucleophilic substitution to give halogenoalkanes. Okay, first step, which is preparing the radical, you have HBr, which is that compound, and you have your radical, so it's completely dissociated to hydrogen and bromine ions. So this is our nucleophile, Nu, which is negative. It's always negative, it carries 2 electrons. So this bromine radical will attack, this is ethanol. The bromine will attack the ethanol, and where does it attack? Remember, it's always attacking the carbon carrying the hydrogen and attached to the OH. So this is the carbon that the nucleophile is going to attack. And as we have learned, always the negative charge attack, or the one with the more electron density, in this case it's bromine, it attacks the CH2, the carbon attached to the CO. So what happens is the electrons move from here to there. Actually, the mechanism, you don't have to learn it. It's not required. So when ethanol reacts with the radical or the nucleophile, which is bromine, there is a substitution. So a substitution means the OH is removed and the Br is replacing it. Now you have the OH which reacts with the hydrogen from here and gives H2O. So to write the reaction more clearly, so you have CH3, CH2 ethanol, and OH. This is the functional group reacting with HBr. HBr will become H and Br. So the Br is our nucleophile. The nucleophile will attack this carbon and forms a substitution. So it's CH3, CH2, and Br, and the hydrogen left will be attached or react with the OH and forms H2O. Okay, this is an easy question. Now for the combustion. Remember combustion? The first reaction, or the first type of the chemical reaction, was about oxidation using the acidified potassium permanganate or chromate, and we have learned that the color can change, and alcohols actually, the primary alcohols, remember that? The primary alcohols in the first oxidation turns to aldehyde. First oxidation turns into aldehyde. And then the second oxidation, this is O. The second oxidation turns it into ketone. For the secondary, it can only be oxidized once and turns to ketones directly because it has only one hydrogen. And for the third, actually cannot be oxidized because there is no hydrogens attached to the carbon. Now, combustion means burning in existence of oxygen. So if you have ethanol and you burn it, you got same thing. This is the same results. You get every time you try to burn a hydrocarbon. Hydrocarbons, remember, are a good source of fuel and energy. So when you burn the source of fuel and energy, you get carbon dioxide, water in form of vapor or liquid, plus energy. Of course, this reaction is exothermic reaction because it produces energy. Now, the dehydration. You know what's the meaning of dehydrating something? Dehydrating something means you remove the water from that thing. So, what is the physical conditions you need to eliminate for the elimination? This dehydration can also be called elimination reaction. Elimination reaction because you're actually eliminating. Eliminating means canceling or removing. So, in elimination reaction, you're actually removing the water from the alcohol. That's why it's called dehydration. Dehydration means removing the water or eliminating the water out of the alcohol. So if you remove the water from the alcohol, actually it turns to alkene. Okay? Again, you have two alternatives. This is the experiment. Dehydration of ethanol actually gives ethene. Remember when we studied about alkenes, we said when we react alkenes with water, it gives alcohols. So actually this reaction is the opposite of that. Instead of adding water, you're removing water from alcohol and turns it back to alkene. Remember, we said alkene plus H2O gives alcohol. So this is actually the complete reverse of that reaction. So you're taking the alcohol and you're removing the H2O, which is dehydration or elimination reaction, and it will give you back the alkene. So if you're having ethanol, removing the H2O becomes ethene. Easy, right? So, simple way, this is your reaction. You have ethanol and you have a catalyst. You need a catalyst for this reaction, which is aluminum oxide. It turns back to ethene. Here's the double bond and a water molecule. The water molecules actually come as liquid vapor. To make a few test tubes of ethene, you must use this. This apparatus actually is used to turn the ethanol into ethene. Okay, you just put the ethanol there and you heat it. When you heat it, of course, the water evaporates. And this is the aluminum oxide, which is our catalyst. Okay, the aluminum oxide actually would be difficult to imagine the scaling up to this point. So when you heat it, the water or the vapor actually goes through that tube and it's there. It's collected there. But why it's used underwater? It's collected underwater because ethene actually does not dissolve in water. That's why it's separated. The water goes down and the gas goes up. Okay, this aluminum oxide actually used, okay, this is where some ethanol in the flask are passing the vapor over aluminum oxide heated along the tube. So actually this is where the vapor passes through to the water and then to the tube. Now we have this reaction, the reaction with alkaline aqueous iodine. This is the last reaction for alkali halides. Alkali halides or halogenoalkanes as we used to know them. For the ones containing Cl, chlorine or iodine, there is different ways of making them. Okay, if you want to make chlorine, alkyl halides that have chlorine or iodine, there are different ways. For chloroalkanes, okay, for this reaction, it has to be made by reacting alcohols with phosphorus, chloride or third chloride, PCl3, or you can use PCl5, or you can use sulfur dichloride oxide, SOCl2. So again, to make chloroalkanes, you use alcohol and one of these three options. PCl3, that's one, phosphorus trichloride or phosphorus pentachloride, PCl5, or sulfuric dichloride oxide, SOCl2. This is your third option. So alcohol and one of these. So here are two examples. Ethanol reacting with PCl5, that's one option. What is this again? Yes, this is a nucleophilic substitution. Yeah, the Cl, there you have 5Cl, 5 chlorine. So in here, one will go, one chlorine will substitute the Cl there. This is a chloroalkane. And another one will react with hydrogen, HCl, and then POCl3. This is convenient. Okay, let's try it with SOCl2. Again, you will have a nucleophilic substitution. One Cl will go there, substitute instead of the functional group, and then HCl will be formed and SO2. So the hydrogen will react with the other Cl and the oxygen go with the SO and becomes sulfur dioxide. So this is how to prepare chloroalkane. Okay, again, to prepare chloroalkane you need an alcohol and one of these three options. PCl3, phosphorus trichloride, or PCl5, which is phosphorus pentachloride, or SOCl2, which is sulfur dichloride oxide. When you react the alcohol with each one of them, and there you have two examples. The first example with phosphorus pentachloride, you will have CH3, CH2Cl, which is chloroalkane. In this case, what is it? It's chloroethane. Okay, it's chloroethane and HCl, hydrochloric acid, and POCl3. If you reacted with sulfur dichloride oxide, you will have again your chloroalkane. But what if you want to prepare iodoalkane? To make the iodoalkane, you need also an alcohol, red phosphorus, and iodine. First, the red phosphorus and iodine, they react together to form Pi3, and then that Pi3 react with an alcohol, in this case it's methanol, there, and produces, this is a chloro or iodoalkane. This is iodomethane. This is our lesson for today, and here are some questions as your homework. Try to answer them and see you next time.